In an earlier video, I talked about how in 3D, we don't really talk about the x-axis as moving right-left. So let's look at how we would actually draw the x, y, and z axis. So typically, in 2D, we think of our xy axis going this direction. Well, now in 3D, it's like I take this and lay it flat on a table. And so I typically draw my x coming towards us. Let me make that point a little bit. So x, we typically draw, why doesn't my shift key always work? Out this way, and then the y this way. So it's like we're looking down on it. So this is a right angle here. And then our z axis, we have come straight up. So this one is our positive y direction, this is positive z, and coming out towards us is positive x. Obviously, these continue in the other directions, so we've got this is our right angle as well. So right now what we see is we've got one quadrant here for the positive xy, here is my positive zy quadrant, here is my positive xz quadrant. So we see 3 quadrants right now. Obviously, these are all going to extend into their negative directions too. But if we try to add the negative directions, looking at this image, hand drawing it, it gets really challenging. So this is the orientation that we typically think of for x, y, z. However, drawing points in 3D is often quite difficult. So I tend to draw them just laid out flat on 2D, but I could think about my 3D components. So if we come back here to our original point A, -2, -5, 3. So -2 would come back this way, -5 out this way, and then 3 this way. So here's where I would end up putting my A, to be at -2, -5, 3. So that's the 3D plane. For a unit vector, if we're going to come back and formally define it, so a unit vector has a length of 1. And it can point any direction. So if we have some vector v that has components of a, b, c, well, that means that the length of v, or the magnitude, will be square root a squared plus b squared plus c squared, which is highly unlikely to be 1. So if we want to turn this into a length of 1, then I have to divide by the magnitude. So the unit vector we denote with a hat, and I say that that's 1 over the magnitude, and then in the same direction. So this is a parallel vector to v, but because I've divided by its length, it now has a direction of 1. So if we think up here to our vector a, so that would come up to this point. Well, magnitude of a for this vector is going to be root of 29 plus 9 is 38. So then the unit vector for a would be 1 over root 38, -2, -5, 3. So if I think about drawing that in, it's going to look like this. So here's my a hat, and it has length 1, but in the same direction.